All right, let's take what we learned in the last video, noticing all those patterns for multiplying out binomials and Pascal's triangle, to see if we can expand x plus 3 to the fifth without actually having to multiply it out. All right, so I know that those coefficients are going to come from Pascal's triangle. I'm going to save those for the end and just leave a blank for them. All right, but let's go with the patterns that we saw in the last video. X plus 3 to the fifth, we know we're going to have some coefficient from Pascal's triangle. Our first term was always x to the whatever power we were on. So our first term is going to be x to the fifth. And then we saw in each subsequent term, we were losing powers of x and gaining powers of y. So the next term is going to be x to the fourth. And then our y in this case is a 3. We're going to have 3 to the first power. Remember as a check that the exponents on the x and the 3 are always going to add up to 5. That's the exponent on our binomial. Right? So just keep going, always leaving a blank for that Pascal's triangle coefficient, which we'll fill in a minute, losing powers on x, gaining powers on 3. And at each step, I'm going to make sure that my exponents add up to 5. Lose a power on x, gain a power on 3. And then my last term, I'm finally going to run out of x's, x to the 0. You don't need to really write it. And we'll just have our 3 to the fifth. All right. Then we just need to fill in our coefficients. We'll do that from Pascal's triangle. So I'm going to come off to the side here and build my Pascal's triangle. Always start with a 1 and add the two numbers above. So 1, 2, 1, 1, 3, 3, 1. And I want to keep going until I get a row that starts with 1, 5, because that's going to be the row that corresponds to multiplying out a binomial to the fifth power. And we got it in just enough room. All right, so 1, 5, 10, 10, 5, 1. That's going to be my coefficients. So we're just going to copy that row from Pascal's triangle. All right, if you accidentally grab the wrong row, you're going to notice that you either have not enough or too many numbers to fill in your blanks. All we have left to do is to simplify. All right, so I have 1 times x to the fifth. I'm just going to leave that as x to the fifth. Let's see, I've got 5 times x to the fourth times 3 to the first. 5 times 3 is 15. So now I've got 10x cubed times 9. We'll simplify that in the next row. 10x squared, 3 cubed is 27. 3 to the fourth is 81. And the last term is 3 to the fifth, which I think is 243. Let's double check that. Yeah, 243. All right, so we got a little bit of multiplication of numbers to go here. I've got x to the fifth plus 15x to the fourth. In my third term, I'm going to multiply 9 times 10. We get 90x cubed. And I get negative 270x squared from that term. 5 times 81 is 405 times x. And then the last one was 243. All right. And although that was a lot of work, I'm kind of glad I didn't have to do that by multiplying x plus 3 out 5 times. This one's going to be a little smaller. We've got x minus 2 to the third power, so we have less terms to worry about. But this one has subtraction in the middle, so we have to be a little bit careful. With the binomial theorem, everything we figured out was sort of for x plus y to a power. So we're going to have to rewrite this as x plus a negative 2 to the third power. And if we just treat our second number like a negative 2, everything's going to work out. All right, so for x plus a negative 2 to the third power. Again, we'll leave blanks and do Pascal's triangle at the end. We start off with x to the highest power, so x cubed. And then we start losing powers of x and gaining powers of negative 2. So we're going to have negative 2 to the first, lose another power of x, gain another power of negative 2. Again, spot checking at each term that the x exponent and the negative 2 exponent add up to 3. That's our exponent on the binomial. Our last term, we finally ran out of x's, x to the 0, and we just have negative 2 to the third power. All right, so let's build our coefficients with Pascal's triangle. Come over here. Start off with our triangle of 1. Next row is 1, 2, 1. We're looking for the one here that starts with 3 because we're cubing the binomial. And our coefficients are 1, 3, 3, 1. And again, Pascal's triangle should give you exactly the number of entries that you need for your blanks in your expansion. So let's simplify. I get x cubed. Let's see, I have 3 times negative 2. That's going to be negative 6x squared. The next term is going to be 3 times x times negative 2 squared is 4. So I'm going to get a positive 12x. And my last term is going to be adding a negative 8 or subtracting 8. And there you have it. All right, this one has a lot going on. We've got a's and b's instead of x's or y's, and we've got coefficients, and we've got that negative in the middle. So we're going to rewrite this as 2a plus a negative 3b, and just write everything down. So again, we leave blanks for our Pascal's triangle. Start off with the first term, 2a, to the 4th power. And just be careful when we have coefficients that you're going to take that whole first term and raise both the 2 and the a to the 4th power. And then in subsequent terms, we're just going to lose exponents on our 2a and gain exponents on our negative 3b. All the time I'm checking that my exponents add up to 4, and I ran out of room for my last term. We'll kind of tack it on down here. Negative 3b to the 4th. All right, let's build our Pascal's triangle. We're looking for the row that starts with 1, 4. And there it is, 1, 4, 6, 4, 1. And again, I should have exactly the right number of entries from Pascal's triangle. And the rest of this is just a bunch of arithmetic. All right, so I don't need to really write that 1 there. I just need to simplify 2a to the 4th. So distribute that 4 exponent to the 2 and the a. 2 to the 4th is 16. A to the 4th is a to the 4th. And then I've got 4, and let's see, 2a cubed. We're going to cube the 2 to get 8. And then I've got negative 3b to the 1st. Then I've got 6. 2a squared is going to be 4a squared. Negative 3b squared is going to be negative 3 squared, which is positive 9b squared. And I've got 4, 2a to the 1st. Negative 3b cubed is over there on the far right side. Negative 3 cubed is negative 27. And then the last term there, I've got 1, I don't need to write. Negative 3 to the 4th is a positive 81. And then b to the 4th. All right, so we've got a little bit more simplification to do here. And I'm going to rely on my calculator a bit here. So I've got 4 times 8 times negative 3. I get a negative 96. Then I've got an a cubed b. And then in the next term, all the numbers, 6 times 4 times 9, got 216 a squared b squared. My next term is going to be negative because I got 4 times 2 times negative 27. And I get 33 a b cubed. And then my last term is 81 b to the 4th. And just to double check, I've got 1, 2, 3, 4, 5 terms, which is the right number of terms for a binomial expansion to the 4th power. All right. When we get together in class, we're going to talk about what happens when that exponent gets too big for Pascal's triangle to be useful.